Hey everyone, so my name's Paul Omond, here to tell you a bit about my story. But before I begin, a lot of my story is around infections, and I really want to give you something I've learned about infections across my treatment. So this was in 2013. I'd just been to an infectious disease appointment at Peter Mac. I got on the train to go home, and an attractive girl sat opposite me. I sat there and went, do I have the courage to actually say hello to her? I thought, I've just beaten cancer. Of course I do. So I was about to say hello to her, and my phone rang. I had a look at my phone. There was my best mate, Warwick. Picked it up, and he's like, hey, mate, where are you? I'm like, oh, I've just been at an infectious disease appointment at Peter Mac. So at this point, I realized I probably spoke a bit too loudly. The girl quickly looked at me, then looked away, kept talking to my mate, and the next train stop, she stood up. I thought, lost chance, this is her station. She walked, instead of walking out the door, she walked to the very end of the carriage and sat down. What I learned that day, were infections aren't sexy. But let's go back to where my story began. It begins in 2010. I was lucky enough to be living and working in Singapore. I was fit and healthy, and this was one of my hobbies, dragon boat racing. You might be able to see me. I'm the one at the back of the boat wondering when this pain will end. And then in August 2011, I had my 30th birthday. Not that big of a deal, but for me it was, because every single month after that, I got sick. I'd get a cold nearly every month. I lost my vision in one of my eyes one month, came back luckily. I didn't think too much of it because everyone says life's downhill after you turn 30. But things came to a head for me in March 2012. I got to my office, sat down at my desk, and I just couldn't stop shivering. So I went to the doctor. The doctor took one look at me and said, well, it's clear to me that you have the flu. Gave me some medication and sent me home. I got home. The next day I felt a bit better, but then 2 days after that I felt terrible. I suddenly had developed vomiting and diarrhea as well as the flu-like symptoms. So I went to get a second opinion, and that doctor looked at me and said, well, clearly you just have food poisoning, take this medication. Took the medication, and the next day was probably the worst night of my life. I remember lying on my bathroom floor because it was the only place cool enough, and I was vomiting and I had diarrhea. Didn't even have the strength to get to my phone to answer which my girlfriend was calling me. Next morning, I did get to my phone. I messaged my girlfriend and said, hey, I'm not dead, but I'm not in a good way. She raced over to my apartment and said, you're going to a doctor. For me, I'm like, I didn't want to because I had diarrhea and the thought of getting in a cab was terrible. But lucky for me, she actually forced me to go. That doctor just took one look at me and said, you're sick, you're going to a hospital. So I went to a hospital and I spent a week in a hospital there at Singapore. They didn't really know what was wrong with me. They ran a lot of tests. Then eventually the doctors walked into my room and told me the words you actually never want to hear. Turns out I have a rare form of leukemia called hairy cell leukemia. My doctors told me that if you were to get a cancer, this is the one you want. So I was full of optimism, thinking we'll get this treated in Singapore, I'll stay here, I love living there. That optimism just disappeared pretty quickly. And the reason is because of my weight. So when I got into hospital at Singapore, I was a healthy 76 kilos. Within 3 weeks, I was an unhealthy 58 kilograms. The shocking thing to me is I noticed, but my doctors didn't. And it got to that point where I was like, for the best course of treatment, I think I really need to come back to Australia. Lucky for me, my parents were here working with Peter Mac to find out if I came back, how could I be admitted? So on Good Friday 2012, I landed back in Australia. Very next day, I was in at Peter Mac. Whilst here, still ran a lot of tests because the vomiting had stopped, but I still had diarrhea. Eventually, Peter Mac put me on a chemotherapy treatment, which is a 5-day treatment, 1 hour a day hooked up to a drip. So pretty good. After the 5th day, I was actually scheduled to go home and recover from home. I remember lying in the ward, waiting for pharmacy to deliver my drugs. And I got up to go to the bathroom and I nearly passed out. So my dad helped me back onto my bed. I turned to mum and I'm like, just keep buzzing the nurse. Within no time, my nurse, and then followed by a lot of doctors, were around me. It's quickly determined that I was actually bleeding from the bowels. So Peter Mac made the decision that they would transfer me to St Vincent's because St Vincent's was better equipped for emergency surgery. So I got to St Vincent's and my surgeon there tried to stop the bleeding without putting me under. When that was quickly apparent that wasn't possible, she goes, "I'm sorry, Paul, we're going to cut you open and work out what's going on." For me, I got put under. 20 bags of blood later, I woke up in ICU looking like this. So what had happened when they got in there, half my large bowel had died. So they took out half the large bowel and gave me what's called a temporary ileostomy. For those who don't know, that's where you have part of your small bowel coming out and opening in your stomach and a pouch attached to that. That's where your fecal matter collects. For me, it was temporary because down the track, my small bowel would be joined to the remaining part of my large bowel. I then spent 2 weeks in St Vincent's before being transferred back here to Peter Mac. When I got to Peter Mac, my stoma nurse, who was also my wound care nurse, took the gauze off my wound and realized that I was having fecal matter just go into my stomach. Unbeknownst to me, my stoma nurse at St Vincent's had cut my pouch wrong, which meant I just had fecal matter leaking into me. This is where the infection battle starts. So I already had picked up an MRSA and a VRE from being a really leukemia patient. But with the fecal matter leaking in, suddenly I picked up a fungal infection called Candida. Later on, I picked up another infection called CMV. This meant while I was in Peter Mac, I was in and out of ICU. I was on a lot of antibiotics and I lost a lot of weight. I remember it was a big struggle for me to eat. One day my dietitian came into my room and said, "Paul, I have one goal for you today. The one goal is you need to drink 2 of these." I look at it now and I think, well, it's a simple goal. But I remember back then, that was a huge battle. I could drink half of that in a day and that was it. But eventually, I did start eating better. The infection started clearing up. And then finally, 4 months after first going into hospital, I was released in July 2012. When I was released, I was a very light 51 kilos. So my dietitian told me, "Don't really care what you eat, you just need calories." I still struggled to stomach anything, but I thought, well, this is my childhood dream. I can eat anything I want. Because I struggled to stomach anything, I drank my calories. Really put on some weight, but I actually found it actually had a negative impact on really my mind. I don't like eating unhealthily for an extended period of time. I didn't feel good about myself. I was depressed. So I shifted my diet. I started exercising more. I started eating healthy again. For me, my primary goal was the next surgery I had. I didn't want to be stuck in hospital. Lucky for me, that surgery came in February 2013, where they joined my small bowel back to my large bowel. 5 days after the surgery, I was still in Peter Mac, waiting to pass something, go to the bathroom, and I got this excruciating pain in my stomach. So I buzzed my nurse. She came in, and like you are when you're in hospital, rate the pain from a 1 to a 10. I usually rate the pain a 9 if it's a 10, because I like room to move. But unfortunately, this was a 10. So she gave me a morphine jab and told me she'd come back in 20 minutes. 20 minutes later, she came back and the pain was still a 10. So she gave me another jab of morphine and came back 20 minutes later. It was still a 10. So the next morning, my surgical team arrived and cut me back open. Sure you understand now by this slide, this is not a good slide. When they cut me back open, they found a leak. So the joint from my small bowel to my large bowel unfortunately burst, which again led me to reversing the ileostomy. So they brought my ileostomy back out and it meant I got more infections. Not actually sure what these infections were, but it meant 3 extra weeks in hospital. So how's this look from a timeline perspective? Well, I was diagnosed in May 2012. I spent 4 weeks in hospital, 3 weeks in Singapore, 1 week here at Peter Mac. I then started my chemotherapy treatment, which was 1 week. After the complications directly after chemo, I had 2 weeks in hospital recovering from surgery. Due to a leaky stoma, I picked up a lot of infections and spent an extra 10 weeks in hospital. I was finally released in July 2012 to come back in February 2013 for 1 week of surgery. Complications in that surgery left me having an extra 3 weeks in hospital. I'm happy to say, finally, in September 2014, my ileostomy was reversed successfully with no infections, so it was only 1 week in surgery. So what have I learned by this? Number one, gut infections are not fun. Clearly, you could see on my timeline, I spent over 3 months in hospital fighting infections which arose from my gut. That's a big risk to my health. It's also a big burden on our healthcare system. Number two is how much diet plays a big part on this. We all know that diet's important to keep us fit and healthy. But also for me, mentally, having a good diet is super important. Third thing I learned, if a good-looking girl sits opposite you on the train, don't answer the phone from your friends. Thank you very much.
Well, that's a story and a half, isn't it? So thanks so much, Paul, for sharing your story with us. Next speaker I'd like to introduce is Professor Karen Thursky. So Kaz is an infectious disease physician, the Deputy Head of Infectious Diseases and a clinician researcher working across a wide variety of areas. Her goal is to improve patient outcomes from infection and sepsis and to improve the quality and use of antimicrobials. Karen will introduce the concept and talk about the impact of probiotics and antibiotics. So please join me in welcoming Karen.
Thanks, Jerry, and thank you, Paul. Paul is actually a co-investigator on our National Centre of Infections and Cancer, because it's just, as you hear, it's so important to have patients who have lived experience, because it means that what we do is much more relevant. These are the sort of things you're probably reading all the time, Facebook, media, Twitter. I'm obsessed about it. You must be obsessed about it. And a little backstory for me is a long time ago, I did a clinical nutrition degree and realised that it was going to be pretty hard yakka being a dietitian, sorry Rose, and went and did medicine. So it's very nice for me to come back 25 years later to do something which is really close to my heart. And hopefully today, not only are you going to find some things that you didn't know and help live your life more healthily, but also to help us decide what we're going to do here at Peter Mac in terms of directing the sort of clinical research that are going to answer the questions that you have today. So please contribute and put your questions into Slido. No questions too stupid, and we'll attempt to answer them. So this is just a rundown of what's going to happen today. So you heard from Paul. I'm going to define some of the terms that he's spoken about. Rose is going to talk about the nutritional aspects. Amy, we're very fortunate to have from Deakin Uni talk about the gut and brain axis, and then Monica's going to talk about poo transplants, which actually hit the Guardian newspaper the other day. And then we have a wonderful panel, including Shanine Sender, who's not here yet, who's one of the oncologists. So you might not realise this, but our body has many, many more microbes in it than there are stars in the Milky Way. And I'm not just talking about bacteria. We have bacteria, viruses, phagiomes, archaeomes, and fungi. So while we'll be talking a lot about bacteria today, they're actually only a proportion of what's in our guts. We actually have microbiomes all over our body. So we have a different microbiome in the mouth, in our armpits, in our skin, in our gut and in our lungs. And all of those microbiomes react in a different way when we have antibiotics or other disease. Today we'll be focusing more on the gut, but a lot of the lessons are going to be similar to what we're talking about. And the actual weight of it is huge. It's pretty scary, isn't it? Most of the microbiome is in our gut, and we'll talk about some of the methods that we investigate the microbiome. But a lot of it is looking at the genes and the genome-wide sampling, and the methodologies that we do are looking at the genes that are in the microbes that are in the gut, and that includes things like resistance genes to antibiotics and antimicrobials. So when you are born, when you're a fetus in your mother's tummy, your gut is actually sterile, and there is a difference between breastfed babies and non-breastfed babies, and that's also been something that you would have heard in the media about the type of microbiome in the gut of a breastfed infant versus non. And as you start to grow, very early on in childhood, you start to get a diversity in your microbiome. And the word diversity or variety of bacteria is very important in our gut. So if you lose that diversity, you're shifting towards an unhealthy gut microbiome. And by the time you're an adult, you well and truly have particular sorts of bugs in your gut. And then as you age and become older, you start to get a change in pattern. Those change in patterns, some of those bacteria seem to be associated with some of the diseases that we see in aging human beings. And our own microbiome is unique. So how you were delivered, your genetics, your diet, as you'll hear, exposure to antibiotics and antimicrobials, and your diseases will all impact on your microbiome. It's like your fingerprint. So this is a very general cartoon, really, to try and link what we're talking about today. We can link the diversity of our diet and what we eat to the bugs that develop in our gut. Those microbiota, those bacteria produce metabolites. Some of those metabolites you know very well, vitamin K, for example. Short-chain fatty acids, which are very important for our healthy gut. These are produced by the gut, and the metabolites determine whether or not there is evidence of disease. Now, when you have a disruption or loss of diversity, we call it dysbiosis. So you will sometimes see the word dysbiosis used, and it's really incredible that many diseases in our Western civilization appear to have some relationship with gut microbiome. And you can see many of those things. The obvious one that Paul talked about was antibiotic-associated diarrhoea, a lot of rheumatological disorders. There's potential links and associated with autism, cancer for sure, particularly colorectal cancer. For a long time you would have heard if you eat a high fibre diet you'll prevent colorectal cancer. That is a true association. Dental caries, mental health disorders, which Amy will cover very well, inflammatory bowel disease, obesity, diabetes, Parkinson's. The list goes on and keeps on growing. And they're really, I think all of us is becoming very conscious of the fact that our gut microbiome is like another organ of our body that we need to be looking after. So this is a more detailed that cartoon that I showed you before. This is showing a little bit more detail. So all these things up the top here, the lifestyle and the diet, alcohol, smoking, stress, how much protein, fat and fibre, your own individual unique microbiome, as well as the other factors like your genomes and genetics and ageing, produce a healthy metabolome or not. If things go a bit pear-shaped in any of those, it will alter the so-called metabolome. They're the metabolites we're talking about, and Fabienne will talk about them a little bit later. And these are things that you will have heard of before, of course, vitamins, amino acids, fatty acids and bile acids, all required to keep our gut healthy and our body healthy. And when the metabolome and the microbiota gets altered, you do start to see the association with these diseases. This is a very simple graphical representation of a healthy gut and this so-called dysbiosis. So it really is about loss of diversity. And many of the techniques that we look at the moment in terms of measuring your microbiome really reports on how diverse your gut microbiome is and not. And if it's not diverse, what are the common patterns of bacteria in your gut that might be associated with disease? It is a little bit simplistic because I think there's a lot we don't know, and that's why we're here today. But they're the sort of things that we look at. A lot of our patients that come to our infectious diseases clinic do start to ask us now that they're worried about taking antibiotics. Now, infections are serious. Infections, particularly bacterial infections and sepsis, need antibiotics. You can't avoid antibiotics if you have a real infection. But unfortunately, the double-edged sword is that when you do take antibiotics, all of them will impact on your gut microbiome. And what happens? Well, what happens is you lose that diversity. And that can last from months to years. And this is an example of a patient who had a diverse gut here, microbiome here, was given a course of antibiotic, completely wiped out all the bugs except for a particular kind, and then 12 months on started to grow some other ones back, but it never quite got back to normal. So that's a sort of a visual example of what might happen. The other thing is we do know that you have antibiotics. There's lots of things going on, genes passing in between the different bacteria in the gut, and that's why we do see that emergence of antimicrobial resistance and spread between the bacteria in your gut, which then of course can go into the environment and shed to other patients, etc., etc. So antibiotics, we need them, but we need to be cognizant of the potential impact on us. Rose is going to come after me, but I just wanted to briefly mention a couple of concepts. You've got the word prebiotic. Put your hand up if you heard of prebiotic. Probiotic? That's good. So prebiotic was not something that a lot of people knew about before. I think the community understood it less than probiotics, which you recognise in the, the Yakults and the pills. But the prebiotics are these non-digestible substances that act as food for the gut microbiota, and they stimulate the growth of healthy bacteria. And Rose will specifically be focusing on the type of diets that support healthy prebiotic diets. Probiotics are actual live bacteria, and you might recognise these names: Lactobacillus, Acidophilus, Bifidobacteria. You will know these from Yakult and yogurt and the other things that you take. And they can be in fermented foods like sourdough bread and kimchi. Kimchi is very popular, of course, now. They're mass marketed. And in one study I read, 3.5% of college-educated adults in the US take a probiotic. That's a lot of people taking a probiotic. And it will be impacted. These strains will be impacted by diet and antibiotics. So what about probiotics? Well, unfortunately, I do have to say to you that there's a huge amount of marketing around the benefits of probiotics, but really the quality of the clinical trials assessing their benefit have been of very poor quality. So there are many so-called Cochrane reviews or systematic reviews where they've tried to demonstrate evidence for probiotics, and there are very few true benefits at the moment. That might simply be because we haven't done the right sort of trials, the right sort of investigations and outcome measurements. A lot of these are not what we call high scientific quality trials, and a lot of them have been done in patients who are already healthy. So we can tell you that they might work in healthy patients, but that does not answer the question about whether they're safe and effective in patients who are very sick. However, there is a couple of true statements, and one statement is that they seem to be of moderate benefit in patients who take antibiotics to prevent antibiotic-associated diarrhoea and Clostridium difficile diarrhoea, which is, I think, Paul, you had, didn't you? We call it C. diff, a very nasty and ends up causing very severe diarrhoea that leads to surgery in very severe cases. And Fabienne, who is our French woman in the room, tells me that in France for years and years and years, it's quite normal to be given a probiotic when you're prescribed an antibiotic in France. So there are cultural differences in how these things are used as well. They may also be safer in patients who are not immune compromised. So this causes an issue in obviously our cancer patients who are both immune compromised as well. And it looks like, particularly in children, the use of probiotics might reduce the incidence of upper respiratory tract and duration of illness. So maybe, yogurt and probiotics might be helpful for the kids. What about in cancer? Well, this is this is one of these big reviews of all the clinical trials, and we don't have evidence really to say whether they're effective and safe. But it looks like they, again, might be helpful in reducing diarrhoea and duration of fever, perhaps reducing the incidence of sepsis and bloodstream infections related to central lines. But there are definitely some case studies of serious infections where the probiotic has gone into the bloodstream and caused sepsis, particularly in very highly immune suppressed patients like patients with leukemia or bone marrow transplant. And the other concern already when you have an immunocompromised patient is you've got this circulating adding these new bacteria into the gut. You've already got antimicrobial resistance like Emma Golden, Staph and VRE. What are we doing? Are we potentiating that risk? So, which antibiotic should I choose? And there's not very much to help us with that, but I got this off the internet, and I thought it's useful to show you when you are going into the supermarket and there's rows and rows and rows and rows and rows of probiotic jars. How do you read them? Well, this is where you need to look really, because it's about the number of what they call CFUs, colony forming units inside that inside the pill, and I'll show you in a minute what that means, and it will tell you about that. And you should also be aware of some of the claims storage. Some of them need to be stored in a particular way. So learning how to read a probiotic label, like any medicine, there's certainly significant concerns emerging now because they are being used like drugs, which means we need to make sure that they're appropriately manufactured, have been appropriately stored, and the Food and Drug Regulation are going to probably start putting on far more restrictions in the claims that are made around how effective they are. So keep your eye out for that. So the Dutch, bless their souls, did a fantastic study where they did a big review of all the studies around the role of probiotics and diarrhoea. And then they went to their supermarket shelves and chemist shelves and picked out every single product on the market in the Netherlands and gave it a ranking from 1 star to 3 star. So this is the figure you need to know. So if you are going to be taking a probiotic, you need to make sure that it has at least 2 billion CFUs on the label, which actually most of them do. And then they decided to try and work out which ones were effective. So this is what I can tell you. So there's 2 things to take away from this study. One is that having probiotics, you probably don't get sufficient amount of probiotic in a dairy product like yogurt. And there was only one product in the Dutch market that met the colony forming unit count, the CFU count, and that was Bistanone. So it seems that having probiotics as a supplement or a pill is more effective. Of all the different ones, the ones that had mixed 4 or 5 or 6 or 7 probiotics were given 1 star or no star. The Lactobacillus rhamnosus GG, so when you see the label, it will actually say that. Like for a Swiss, I think that is what's in the Swiss one. That got given 3 stars as the most effective compared to Bifidobacterium saccharomyces and Lactobacillus casei. So 2 little things to take away from the probiotics. Obviously pretty safe if you're a healthy person. Need to think twice and seek advice from your doctor if you're a cancer patient, whether or not it's safe. And then if you're going to take them, it's probably better to take it as a probiotic supplement and pick the one that's got that with more than 2 colony forming units. So I'm going to finish there and we'll take questions after, and I'm going to hand over to Jerry to introduce Rose.
Thanks, Cass. So I hope you've all got your Slido open, and we'll go back to that slide before the panel to remind you what the code is, etc. So you can pop in your, do you want to put it up? Pop in the code D662. So you can be submitting your questions now. So next I'd like to introduce Rose Rocker. She's a senior clinical dietitian who's been at Peter Mac for over 10 years. She's a Masters of Public Health and an interest in the gut biome. So thank you very much, Rose.
Okay. Hi everyone, I'm really excited to be talking to you about the gut biome. I think it's such a hot topic, and I think that this event sold out in 2 days. So I think that everyone here must be very keen. So the things I'm going to talk to you about today are, does what we eat change our gut microbiome? What should we be eating? And because it is a cancer centre, we're going to talk about some considerations for cancer care. So starting with, does what we eat change our gut microbiome? And I think we've already heard a little bit about that. And the answer to that is definitely yes. It's not the only thing that impacts the gut microbiome, but it's certainly a significant one. And if you think of what the gut bacteria does, it actually makes sense that the diet impacts that. So one of the jobs of the bacteria in the gut is to break down any undigested or leftover food from digestion, which makes it to the large intestines. So we eat, the digestion happens earlier up in the small intestines, and then in the large intestines you get leftovers. And those leftovers are then broken down or is a fuel source for the bacteria in the gut. So different bacteria will feed off different food sources. So therefore it makes sense that what you eat impacts those bacteria in the gut. So eating a variety of foods, eating a healthy diet will support the growth of certain bacteria. Having a very limited diet and having a typical Western diet of high fat, high sugar foods also means that you impact the gut biome in a not so good way. And we see this all around the world where we look at the gut biome of different populations, look at their diet, and there's big variations from what we eat with what African communities eat, who have a much higher fibre diet, and their gut biome is very different to our gut biome. And if that hasn't convinced you, I have more evidence. So the key message of the things we can do for our gut biome is eating fibre. So most of us eat about 15 to 20 grams of fibre a day, but the recommendation, what we need to keep our gut healthy, is 25 to 30 grams of fibre. We need different types of fibre, and different fibres affect the gut in different ways. And I'll show you that. So a lot of people put their hand up for prebiotics. They are a special type, knowing what prebiotics are. So they are a special type of fibre that promotes the growth of beneficial bacteria in the gut. I've got some examples of some food sources there. So a lot of your greens, particularly things like onion and garlic, are very good. Legumes are very good as well, some fruits and different types of vegetables. There is a more comprehensive list of prebiotic foods. I think I took that slide out thinking I might run out of time, but I can give that to people, or you can easily Google it. So the reason these prebiotics are important is because they are the fuel source for the bacteria in the gut. So they produce free fatty acids. Don't worry too much about the term, but they do produce something. We eat the food, these prebiotics, when they reach the gut, become the fuel for the bacteria, and then that bacteria in turn for us does us a favour and produces these short chain fatty acids. So the short chain fatty acids are important. I tried to find the least technical diagram I could to show you what short chain fatty acids and explain the role of short chain fatty acids are. So when the bacteria produce these short chain fatty acids, what we get is, let's see if this pointer works. If you kind of look at this junction here, you can see that it's a nice tight junction, and those short chain fatty acids are thought to be responsible for that. When you have over here that bigger gap, you can see that the larger particles there can then move from the large intestine into this lower part, which is the bloodstream. So I'll try and explain this a little bit better, because it's important to understand this one and how they do their role. So we eat like I've already said, then we promote if we can promote the bacteria that produce these short chain fatty acids, these short chain fatty acids then are the fuel source for the cells in the gut. So if the cells in the gut are getting these short chain fatty acids, they feel healthy and your intestines are healthy. If they aren't, you get inflammation. When you get inflammation, you get this. So you get the response of inflammation, And then you get a secondary response which relates to the immune system. So you get this heightened immune response when you get particles going from the large intestines through these gaps and into the bloodstream. It sets off a cascade of other things that affect your immune system. I hope that's clear. Does that sort of, I wanted people to kind of understand that, yeah, we want to feed the bacteria that promote these short chain fatty acids that then keep the lining of our intestines healthy. And resistant starch is another type of prebiotic. It's another type of fibre. And this one's interesting because it's been linked a lot with reducing the risk of bowel cancers and things as well. And this comes in, so when we think fibre, we think, whole grains, and we think wholemeal breads and things like that. In fact, even pastas, rice and potatoes, when they're cooked and then they cool, can actually produce a type of resistant starch that's beneficial for your bowel as well. It's also naturally found in oats and in a lot of beans, lentils, and the legume family of things. And this particular starch also is beneficial for your gut. This slide here highlights how foods have variable types of fibre. So foods will have dietary fibre. It's combinations of resistant starch and prebiotic fibre. It's really important to eat a variety. I think the key message is to not get your fibre from one source. You want to get your fibre from a range of things. So you want to make sure that in order to get your 30 grams, you'd need to eat high fibre cereals or whole grain wholemeal breads. And then you want to meet your requirements for fruit and vegetables, which is 5 serves a day of vegetables and 2 serves a day of fruit. And if you do that, you're likely to get a good balance of the prebiotics as well as the total fibre intake. Another point to mention with fibre is if you have a low fibre diet and suddenly you decide that I inspire you and then you go home and eat a lot of fibre, because your gut is not set up to digest that yet, you're going to have probably bloating, gas, and a lot of discomfort. So you want to introduce the fibres slowly and make sure that you give your gut a chance to adapt to it. This slide I really like because it kind of visually depicts how quickly your gut microbiota can change. This was a study done by Monash University. It's still unpublished, but I have spoken with the researcher and discussed the study and these results. Now, you probably can't see all the names down the bottom, but that's actually okay. I prefer you not to get too caught up in that. The important things with this slide is to look at the colours. So we're looking at there's 2 variable shades. So you've got your red ones, which are your firmicutes. They're the ones that respond more to a high-fat, high-sugar diet. So they're the ones we want a bit less of. Then we've got the green ones, the Bacteroides family. They are the ones that produce the short-chain fatty acids that I was talking about. And the short-chain fatty acids keep our gut healthy, reduce inflammation, help our immune system. So it's those greener shades that we want more of. Overall, we want lots of diversity. We don't want the red ones completely gone, and we want as much diversity in the picture as possible. But so the first one first circle you can see there, that was just baseline. So that was the group that they took and they measured their microbiota before the study started. And their total fibre intake was around 15 grams of fibre a day. So you can see that's the picture they had. Lots of red, not so much of the green. Then they implemented their intervention, which included 30 grams of fibre. So this low prebiotic fibre, you see the second wheel, they had 30 grams of fibre and only 3 grams of the prebiotic fibre, which is not a lot. You could easily meet that with some garlic and onion and some lentils. Not a lot of probiotics there in that group. But you can see just by changing the fibre, how much greener they look. So there's a lot less of the red and the pink and there's a lot more of the green. And then with the moderate prebiotic fibre, that was about 8 grams of prebiotic fibre in that one. Again, some changes. I don't know, you could probably ask the infectious disease people what that actually means. I don't know. All I take away from this graph is that including fibre is beneficial. So whether the prebiotics is important, but including the 30 grams of fibre means that you get a lot more of the green shades and a lot less of the red shades. Interestingly, in this study too, they had a high prebiotic fibre that they had to actually take away from the study because people got so uncomfortable. So you can overdo it. You don't need to eat. More is not always better. Just having that normal 30 grams with some prebiotic is enough. You don't need to go crazy on it. So that is the fibre talk. So hopefully that's been enough to make you want to go home and eat some high fibre foods and eat lots of fruits and vegetables. In talking about pre-cancer, you know, how we move this into the whole cancer realm, pre-treatment, I guess the goal is to improve nutrition in order to get you ready for your treatment. We want you to come into treatment being in the best nutritional state you can. So we want people with a good, healthy weight. There's no study is known whether, you know, if you do that, does that mean you get less side effects? Does that mean that then your gut biome protects you from things like mucositis, or which is sores in the mouth that people can get, which can relate to bacteria as well? Does it mean you get less diarrhea from your chemo? We don't really know. Would be nice to know, but we don't really know what that actually means. There is some emerging information that's quite interesting, very early days still, but it's in immunotherapy. So patients who are getting immunotherapies, which you may not all have heard of, but it's one form of treatment that people can sometimes be offered, particularly in patients with melanoma. So this study, it was a study done in melanoma patients on immunotherapy, and they found the people with the better gut biome were better responders to treatment, as opposed to the people who didn't, whose gut biome was not as diverse and not as healthy. So a little bit of a study isn't enough to sort of make recommendations. We have no recommendations at the moment, but it pricks my ears, it makes me interested. And given that what you need to do to improve your gut biome is eat healthy, I mean, there's no negative effects of that. So to me, I would feel that, yeah, it's a good idea pre-treatment to try and optimize your gut as much as possible and come into treatment being of a good weight, a good healthy weight, and eating as healthy as you can pre-treatment for your gut biome as well. Once we start treatment, things get a little bit different because a lot of treatments can have a lot of side effects that affect your weight. So you can lose your appetite quite quickly, you can have nausea and vomiting, taste changes, swallowing difficulties, all sorts of things related to treatment, which can then lead to weight loss, and that leads to worse outcomes. And the evidence is pretty clear that if you lose weight during your treatment or you become what we call malnourished, by malnourished I don't mean like Ethiopia malnourished, I mean even overweight people can be malnourished, you're not getting enough calories, you're losing weight, your body doesn't have enough of the energy and protein it needs to make the new cells and keep you healthy. That's what I mean by malnourished. And if you are malnourished, you are at much higher risk of being more fatigued than you need to be, losing muscle, having a decreased recovery time post your treatment, so your body does not have what it needs to heal to make the new cells for you to recover. And it's also, the evidence is pretty strong about increased hospital stays if you're malnourished. So for that, which is a large part of what my job here is to help people prevent that malnourishment. And in order to do that, what we do is we encourage people to increase the fat in their diet, increase the protein, increase high energy foods. And then we also advise about decreasing fruits, decreasing vegetables, and decreasing low energy foods. And that is because if you're not hungry and you can't eat a lot, and all you're focusing on is your fruits and your vegetables, you're not going to get enough calories to maintain your weight. So if somebody wants to lose weight, we say eat more fruits and vegetables, eat more fibre. But if you're losing too much weight, we have to say, no, you need to do the opposite. You need to go for higher fat, higher protein, a fattening diet, anything you feel like eating, basically, in order, whatever it takes just to get your weight to stabilise. But you can see that a lot of our recommendations and what I tell people isn't necessarily good for their gut biome. So it's a little bit hard being a dietitian when you believe in the gut biome, but you also know that the evidence is you know, that you have to maintain your weight during treatment. So I guess this is just my own little tips for prebiotic diet during treatment. And what we'd be looking at is things like adding low volume prebiotic foods. So garlic, onion and leeks, they don't take up much space on your plate, but if you incorporated them, they do keep your gut healthier. So then we would still get those, the cells in the gut as healthy as we can just by including a little bit of those. We think, like I said, there's no studies, there's no evidence to prove that, but it just makes sense to me. The other thing is fortifying fruits and vegetables. So if you're having vegetables, you want to make sure that they're fattening. So you want to put some extra fat on that, extra olive oil, extra butter, white sauce or something like that on your vegetables. You could make smoothies, so you could blend your smoothies with milk and high protein options and then have your fruit that way. So at least you're getting some of the good fibres in that way. And also the resistant starch that we talked about. So you would cook and cool pastas, rice and potatoes, and then even if you heat them up, I didn't say that about resistant starch, but once they're cooked and cooled, you can reheat them without losing the resistant starch. So you can just do those little small things. I don't know if it actually works, but to me it makes sense. It's what I would do. And that's it. I guess we didn't talk post-treatment, but post-treatment would be very similar to pre-treatment and just what the recommendations are for normal healthy people. Key points: eat your fibre, eat a variety of fibre. Don't just focus on bread and cereal. Make sure there's fruits, vegetables, beans, lentils, and a bigger range of colours, a bigger range of different types of fibres is important, and maintain your weight during cancer treatment. And that's it.
Thanks, Rosa, for a really comprehensive overview of nutrition. So we're tracking pretty well for time. So next I'd like to introduce Professor Monica Slavin. Monica's the head of infectious diseases here at Peter Mac and has a 30-year career looking after patients who acquire infections during the course of their cancer treatment. Monica's going to talk to us about fecal microbiota transplants, so poo transplants. Thanks, Monica.
Hi, everyone. So I'm going to talk about fecal microbiota transplants because you may have heard about this as an option for treatment of some difficult to treat bowel infections. I'm going to tell you a bit about the good side of it and the bad side of it. And as it is, we don't really have a perfect fecal transplant at this point in time. So this is recent from The Guardian this week. Patients are no longer poo-pooing fecal transplants. And that's the only joke I'll make about it. I won't say that again, I promise. So what is a fecal transplant? So it's giving one person's healthy gut bugs to another person to treat a bowel infection or inflammation. And to do this, we have to identify a donor to donate the stool that's going to be given to the patient. And that should be a healthy person. And there's actually a bit more to it than meets the eye. So when we have to ensure the donor is healthy, we have to screen the donor because we're actually giving them potentially some of the donor's cells could be around in the stool. We shed cells all the time into our gastrointestinal tract. So we have to make sure that this donor doesn't have any infections, any viral infections, any bug infections in their bowel, and that they're not carrying any highly resistant organisms because we wouldn't like to be transferring those along with the stool transplant. So it's quite a bit of questioning of the donor and working out who's the best donor to use. And generally we use a family member, although it doesn't have to be a family member. Some people feel a bit better about having the stool from a family member rather than someone they don't know at all. And also you can have a little bit more knowledge about what the person's lifestyle is, how healthy they are, if they're a family member rather than someone you don't know. So once screening has been done, then you can go on to collect the sample. And generally the sample has to be collected and processed within about 6 hours. So it can't be sitting around for a long time. There are some limitations about how we screen people. The kind of tests that we use are the tests that we'd use for a blood donor or an organ donor, and they really haven't been kind of well validated for stool. It's quite a different product to blood or to an organ. So there's a lot of interest from the TGA at the moment about trying to form some regulations and rules about how we screen patients, because many of the tests that we're doing to look for resistant bacteria, etc., in the donor are actually tests that we're using to try and identify infection, not, 1 in 10 million bugs that carry a resistant gene. So they may not be the best tests, but they're only tests that we've got at the moment. So once the stool has been collected, it's processed and it's just mixed up and solubilized and put with some salty water to make it into a kind of a slurry. And this can be done in a blender or in a mixer. And then it is filtered and given to the person who needs it. So this is some slides by one of our fellows who did this a few years ago. And you can see going across the top of the page, he's getting the, he's got the slurry there on the right, and he's about to filter it so that you get out any fibre or any other solid kind of material. And he filters it through the gauze along the top, and then once it's in the jar and it's filtered and it's soluble, it's then put into the patient, generally through a scope type of procedure. So it may go in to the small intestine via a gastroscope, or it may go in to the colon via a colonoscope. So usually it has to go directly into the patient and bypass the stomach, because of course the stomach has full of acid, which is going to destroy the bugs. So that's why it has to go in to the small intestine or the large intestine, and that involves a procedure, obviously. You can see the scope over on the left-hand side there, looking down the bowel into the intestine, and the fluid is injected into that, in through that. So what are the side effects? And it has been recognised that there can be some side effects. Many patients who receive it to treat a serious bowel infection report feeling better straight away, but not everybody. So sometimes you can have diarrhea or abdominal cramps, belching, constipation, fever that can accompany the installation of this material. Very rarely you can get serious bloodstream infections where the patient's bowel that you're treating, you're putting this these bugs into the bowel. The bowel is not in a healthy, good shape, and the bugs, as we saw from the slide previously, the bugs can cross across the bowel and get into the bloodstream. And this has been known to happen after fecal transplants. Bowel perforations have also occurred, or the patient actually regurgitates the fecal material that's put into the upper gastrointestinal tract, and it gets into their lungs and causes pneumonia. So there are all these things that can go wrong, and it has to be said that deaths have occurred after fecal transplants when some of these things have happened. So generally, as you can see from the pictures, they're given under very controlled environments in an operating theatre with an anaesthetist present and with an endoscopist present. So when is it used as treatment? And I think the writing here, in the big writing, there's no doubt that it's very effective for treating recurrent Clostridium difficile diarrhea. So that's the kind of diarrhea, that infection that can occur after antibiotics due to a specific bug that causes inflammation in the gastrointestinal tract. And fecal transplants have been widely used to treat this infection and very successful. in the European consensus, they give it a strong recommendation, and so there's strong good evidence to support its use. Where it becomes a little less clear is where it is a refractory Clostridium difficile infection where no other antibiotics have worked, but there is still suggestions in the literature that it can work in this situation. And then there are a whole lot of other areas where it's being investigated, but we just don't know how effective it will be. There are some case reports about people who've had it and it's helped various conditions, including colitis after immunotherapy. So again, we heard about how the normal good gut flora and microbiome can protect against some of the side effects of immunotherapy and also improve the response of immunotherapy. So certainly patients have been given it who've had serious colitis after immunotherapy, but only a very small number of reports. So we're still waiting to get maybe more evidence before it gets a strong recommendation. And it's also being investigated in some other gut diseases like irritable bowel and inflammatory bowel conditions, and even in metabolic syndromes like diabetes. So there's a lot of interest in studying fecal transplants. But as I showed you, they're not quite straightforward in that the screening is not completely well worked out, and there can be complications. So we looked into this area particularly because we had a patient who brought it up to us. They were about to start immunotherapy, as we heard from Rose's talk, and their question in the clinic was, well, what can I do to improve my gut microbiome so that I can have the best chance of responding? And this patient was very set on having a fecal transplant, which she actually did go ahead and get, buying it off the internet. And we weren't quite sure what it contained actually. So it just shows that people are very, very interested and really want information about this area. And this comes from, of course, the publications that are out there about having a good microbiome. But one of the difficulties is these studies have all been done with slightly different methods, and there's no one recipe. So no one is able to tell us you've got to have 50% of this organism plus 20% of that organism plus 10% of this organism. So we actually don't know what is the best makeup of those microbiota that's going to give the best chance of response. So what we do know, and our team reviewed this with the oncology team recently, is that yes, a high diversity does improve response. It can also influence the side effects as well and maybe make you a little less likely to have side effects. And there are an overlap between the microbiome that causes good response and the microbiome that causes side effects. So again, we haven't been able to dissect out and tease out which is the best one to have for the best overall outcomes. And there is a phase 1 study that's undergoing in the US where they're giving fecal transplants from people who've responded well to immunotherapy to people who haven't. So they're transferring that person's gut microbiome to the other. This is a very early experimental study, and I think, you know, we're very interested in the outcomes of this, and I'm sure that along with this study they'll be trying to best characterise what is the ideal breakdown of organisms that's going to offer the best results. So one of the other questions we get asked by patients is, should we take antibiotics? You know, many of our patients, as Kaz mentioned, have to take antibiotics for various conditions. And what are they going to do whilst I'm having cancer treatment? So to answer this question, we will be starting a study here at Peter Mac, which will be led by oncology and contributed to by a lot of the medical physicians here, to follow patients who are having immunotherapy, check their microbiome when they're getting antibiotics, after they're getting antibiotics, and look at overall how it impacts on patient outcomes. So this is just one study that's being planned to try and answer some of these questions. So what are the future directions? This is my last slide. I think we really do need to define what is a good microbiome for treating bowel infection. what's a good microbiome for getting the best response to cancer treatments, for minimising the side effects of cancer treatment, and for treating other bowel conditions. And it might not exactly be the same across all those conditions. It might be slightly different. Again, something we don't know. Of course, there will be studies once we determine what the best kind of favourable microbiome is, there will be studies to intervene and try and treat and prevent infections, but they're a little bit of a way off at present. And of course, we do need agreement on how to select and screen donors and standardised procedures around that so that it's safe and everybody knows what they're getting when they're getting a faecal transplant. And I think also developing the way we give the transplant. And there could be improvements there. As I've showed, it has to currently be given by a scope, and there may be better, safer ways if you could make it into a resistant capsule that resists the acid in the gut and gets into the bowel. That would be ideal. But again, that's something for future research. So I'll stop there, and I think we're ready to go on to the next talk.
Thanks, Monica. That was really interesting, and I think one of the takeaways from that is, don't go and buy your transplant off the internet, and that if you are interested in finding out more about transplants, the best place to start would be with your GP or your treating doctor. Before I introduce you to Amy, I just want to mention that we do an enormous amount of research here at Peter Mac, and one of the things that we're particularly passionate about and what we want to let you all know is that we really want to partner with our patients in research. So if any of you are interested in becoming a consumer advisor for any of our research studies, please leave your details. I'll leave a sheet up there for us to get in contact with you, because we have an enormous number of studies going on. We're always looking for patients who would be available to provide us with advice on participation, etc. And also in service development, in how we develop our services here. We ensure that we always have consumers represented in service development. So if you're interested in that sort of work, please get in contact with us. So I'd like to introduce Dr. Amy Luffman from the Deakin University Food and Mood Centre, where she leads the microbiome research stream. Her research aims to uncover the role of the human microbiome in brain function and mental health across the lifespan, with the ultimate goal of paving the way for novel prevention and treatment approaches. So thank you, Amy.
Hello. So today I'd like to provide a little bit of information about how the brain fits into this gut microbiome picture. You're probably getting a flavour by now that there are more questions than answers. It's a very exciting and rapidly developing field, and I'll tell you a little bit about what we do know, keeping in mind that there are decades and decades of research ahead of us in this field, and you'll probably be asking some of the questions online that unfortunately I'm not sure that I'll be able to answer because we simply don't have the research. But for the moment, let me tell you a few things that we do know. So we've heard already about the microbiome and how there's this community of microorganisms on really every surface of the human body, internal and external. And the gut microbiome, which we'll be focusing on tonight, obviously, is one of probably the most interesting of all of them so far with respect to health and disease, although all are being characterised, even that of the belly button. There's a separate microbiome for the belly button, because the gut has really well-established links to the brain, which I'm interested in, but also to other bodily systems. So, for example, innate and acquired immunity, infection and inflammation, and obviously metabolism and digestion. So I think most of us would have experienced that there is a gut-brain connection that occurs in both directions. It's bidirectional. When we are stressed or nervous, we can feel uncomfortable in the tummy, butterflies in the tummy, that sort of thing. And the other direction is also true. So when we have altered gastrointestinal function, there are signals sent to our brain that enable us to feel things like nausea, feeling of fullness or hunger, and also pain. And then at the higher order level as well, when we're talking about mood, learning and cognitive function, we're starting to understand how the gut is related to all of this. And the microbiome is thought to be one of the really important aspects of gut function that relates to the brain. So there are a number of different types of studies that give us the information that there is this reliable gut-brain link in both directions. So just to touch on a few of them, we have animal studies looking at specific infections and also animals that are bred to be germ-free, so without any microbiome on any part of their body. They're bred in isolation chambers. And these show us that mice and rats in particular, we're looking mostly at rodents but also at other mammals. Those that are lacking a microbiome, particularly in their gut, have very strange behaviour and different brain function to what we'd expect from a normal wild type mouse or rat that has a normal gut microbiome and microbiome of everywhere else in their bodies. We also have supplementation studies of probiotics, antibiotics, and also now prebiotics, largely in animals but beginning in humans as well, showing that supplementing with these things can change brain function and also mental health and mood. We have fecal transplantation studies. We've heard about FMT, and it's great that the concepts have been introduced, so I don't need to do any of that background here, showing that we can actually transplant behaviour via fecal matter, and I'll tell you a bit more about that in a second. We also have a number of human observational studies showing that people with various kinds of psychiatric disorders, everything from schizophrenia, severe depression, and also neurological conditions like Parkinson's disease and Alzheimer's disease, have a different gut microbiome to healthy controls that they're compared to. And of course, there are questions about causality here. Is it the gut microbiome causing their brain disease, or is it the other way around? We're starting to get some evidence that there's definitely some bottom-up, so to speak, effects. But for sure, we know that there's a cross-sectional association. There are beginning to be clinical trials as well, saying if we target the gut, can we affect the brain and mental health? So a little bit about germ-free mice. These are those that are bred in chambers without any bacteria at all. We know that they have an altered stress response to a stressful stimuli. So in mouse and rat experiments, that's often a restraint task where they're not able to move, or electric shocks, that sort of thing. And we know they have increased stress hormone production in response to that. They also have different brain function with respect to their blood-brain barrier permeability, where it's more permeable to I guess, substances within the bloodstream that shouldn't be getting into the brain. The blood-brain barrier is less effective at keeping those things out. And behaviourally, germ-free mice have alternate reports of either increased or decreased anxiety responses to normal stimuli that would normally produce anxiety in a rodent. They have learning deficits, different social patterns when given sort of mice friends to play with, and some increased stereotyped and repetitive behaviour, which is being looked at with respect to autism, because that's one of the features of autism in humans. They also, interestingly, have different metabolism of 5-HT, which is the precursor to serotonin, an important neurotransmitter, and many, many other changes to their brain function and behaviour that give us a sense that having a normal bacteria in your gut is really important for normal brain function. Now, with these mice, interestingly, if they're given a probiotic early enough in life, some of these effects can be rescued. They can develop, their neurodevelopment can track along like a normal mouse, but if it's done too late, then there's this critical window where after that you can't really affect their development. So it tells us also that it's important in early childhood to have, that the gut is important in that context as well. We also know that depression can be transferred. So there are at least 2 studies looking at, one in mice, one in rats, that giving a rodent a transplant, a fecal microbiota transplant from a depressed person, a human, induces changes to their behaviour such that they also look like a depressed animal. And before you say, well, anybody getting a microbiome transplant will probably find themselves a little bit depressed, of course they're being compared to animals that are receiving a transplant from a normal, non-depressed person. So this, I guess it shows us that there's a bottom-up effect here, that if you change the gut, you can change your behaviour and brain function. So this has led to the idea of psychobiotics, which are pre or probiotics, or even symbiotics, which is a combination of the two, that are aimed at changing the gut, aimed at changing the brain via the gut. So can we affect the brain not by targeting the brain in the usual way that psychiatric drugs do, but via changing the gut microbiome? And it has to be said that this is really in its infancy at the moment. We're not at the point yet where we can say, go and buy this probiotic, it'll make you less depressed, or any other kind of mood effect. As you can see, a lot of these are in healthy humans, which has already been pointed out by other speakers. So if there are a couple of studies, one in healthy volunteers and one in people with chronic fatigue syndromes, showing that certain probiotics can improve their psychological distress symptoms. And also there was a study looking at people going under the scanner being shown highly emotional pictures, and looking at the parts of their brain that were more or less active, I guess in a simplified way, to those images, and their responses to that sort of stressful stimuli was different whether they, depending on whether they had had a fermented milk product with probiotics or an identical product that had no probiotics in it. It was non-fermented but had the same taste. Again, we don't know quite yet what that means. We don't know if we put you under a scanner and you have a certain brain response, what is ideal, but it does demonstrate the fact that it's possible to change your brain given what you ingest. We know also from human studies, the simple fact that diet matters for mental health is a really strong indication that your gut is important for your brain function. And this is true across the lifespan. So people who have a diet that's very high in processed foods, saturated fat and refined sugars are up to 50% more likely to have a depressive disorder, and up to a third more likely to have, and if you're having a healthy diet, you're up to a third less likely to have depression or anxiety. And this is just a high diversity fresh food diet, high in fruit and vegetables. Of course, we all know that when we're feeling a bit down, we reach for so-called comfort foods and fast foods. So could this be just that it's reverse causality in effect? Most of the studies that look at this are now onto this fact. It's a really common criticism. And even when you control for people's mood at the beginning and other important things like their socioeconomic status, their education, their access to fresh food, that sort of thing, quality of diet predicts depressive symptoms over time as well. This has been demonstrated right from diet in pregnancy and its effect in children, through to adolescents, healthy middle-aged people, and in older age. So it's really true for everybody. So a trial that was run in Victoria a few years ago aimed to test this idea about diet and mental health link, but with the idea of treatment. So can what you eat actually change your mood once you already are depressed? We think of comfort food being junk food, but of course in the long term this is not really the case. It's perhaps more likely to be the antipasto. So the SMILES trials used a modified Mediterranean diet, which broadly speaking was high in fruit and fresh fruit and vegetables, legumes and whole grains, moderate intake of lean red meat, low-fat dairy, a lot of olive oil, and very limited refined sugars and saturated fat. But the intervention was simply a dietary support program, telling people about the diet, not providing the food, not having any caloric restriction or anything like that, simply education about the diet. And it was found that after 12 weeks, a third of those that had this dietary support intervention, as opposed to just a basic social support intervention where they were kept in touch with but not specifically about their diet, a third of them had reductions in their depressive symptoms such that they were no longer considered depressed. This was in comparison to 8% of those in the social support group. And so this was beginning to be really good evidence now that the diet and mental health is linked even for people who are already depressed, not just for people who are healthy, so not just for prevention. Another study in Australia has replicated these findings in the past couple of years as well. So how does this all work? What are the mechanisms linking gut and brain? They're still being teased apart, and as complex as this diagram is, it's obviously just the tip of the iceberg in the complexity of the whole picture. And it touches on some of the things we've already heard about. So once the diet is entered into the gut, the prebiotic foods that are not digested in the stomach and small intestine are become fuel for the gut microbiome. They, in response, the gut microbiome produces metabolites. These include short-chain fatty acids, which you've already heard about, which are really important for maintaining gut barrier lining. When that gut barrier is not intact, we've heard also that some foreign matter that's in the bowel can pass through to the bloodstream, and this provides an inflammatory response. These inflammatory and immune markers can then transmit messages to the brain about inflammation and change brain function. Also, interestingly, a lot of neurotransmitters that are important for mood, such as serotonin, are synthesized largely in the gut. They're not so much made in the brain. So what happens in the gut is really important for brain function. There's also a nerve called the vagus nerve, which travels from the brainstem right through to various parts of the digestive tract, transmitting messages in both directions. So there are lots of ways in which the gut and the brain speak the same languages. So the good news is that our gut microbiota are modifiable. Some of the things that modify it are out of our control, how we were born, whether we were breastfed or not, where we live, all that sort of thing, how, I guess the aging process as well. But the biggest impact on it that appears to be the case so far is diet. And so this raises the question, what should we be eating, at least for our mental health, which is my area. And the good and the bad news is that it's a boring story. There's no very expensive superfood that you should go and eat to cure everything. There's no silver bullet, but adhering to the healthy guidelines about fresh fruit and vegetable and fibre intake in particular is likely to be your best shot at good mental health. Monash University has some very good resources about prebiotic foods, as Rose has mentioned. This was on their website that I've listed up there, of their list of quite high prebiotic food types. Some of them are pretty hard to come by, like human breast milk. I'm not sure how many people have access to that, but chickpeas, lentils, other things are a lot more accessible. So very briefly, I've already told you that adhering to the dietary guidelines is your best bet, but other hints on foods that are good for the gut-brain axis, which really are foods that are good for you as a person as well as your microbiome, include fermented foods and olive oil, high amounts of fibre from a diverse range of foods, as has already been pointed out, omega-3 fatty acids such as from fish, and polyphenols, which are found in a number of foods like blueberries, but also peppermint and dark chocolate and other things. And predictably bad for the gut and the brain and the gut-brain axis are those highly processed foods, saturated fats, processed and added refined sugars, and high amounts of alcohol as well. I've just got a few resources that you might be interested in. The first few they're scientific articles, but they're easy to read, and they're review papers reviewing this field, and also some websites that provide really useful and easily accessible information. And I found these two books did a particularly good job of translating the research that was current up until they were published a few years ago about how the gut impacts your health and your mental health as well. Thanks very much.
Thanks, Amy. That was terrific. So now we're going to move into the panel discussion, and let's see how Slido works for us. So we've got a series of questions that we'll attempt to answer, and Kaz will moderate the panel.